Hello, welcome. Today let's try to solve Leetcode problem 1786, number of restricted paths from first to last node. So let's first understand this question, and then I'm gonna solve it by the Dijkstra algorithm with I'm gonna use the Dijkstra algorithm with the dynamic programming. Because otherwise if after using the Dijkstra algorithm, if I use the BFS, I gonna have a time limited exceeded. Yeah. So let me first explain this problem. So we are giving a number of nodes, so from node 1 to node n, and we are also giving the edges. And for the blue color, it is just means the shortest distance from this node 1 to node 5. For example, it is 4. The shortest distance from node 2 to node 5, it is 2. Yeah. But we want to find the decreasing distance. So for example, from node 1 to node 5, what is the decreasing distance? It means it is 4, 1, 0. This is 4, 2, 0. And can we find another one? Let's check another one. 1, 2, 3, 5. So it is 4, 2, 1, 0. I mean the distance should always be in decreasing order. And for the node, it is 1, 2, 3, 5. So how many are there? So in total, there are 3. Why? Because we are giving like this one, the distance to last node x. So this is the shortest distance. And here we have another condition. So this zi should always be more than the distance to last node zi plus 1. So this means this is node 1, this is the distance is 4, should always be more than the node 2. So the distance from node 2 to last node it is 2. The 4 should always be more than 2, 2 should always be more than 0. So in total, there are 3 for this example. Yeah. Now let me first try to write the Dijkstra algorithm. Yeah, because basically I'm going to calculate the distance. So these blue colors are not given. I'm going to calculate these blue colors. So I'm going to start from node 5 to node 1. But basically, I'm gonna transform from node 0 to n minus 1 because this is easy for calculation, at least for me. So I'm gonna prepare a graph, would be a default dict, and inside it will be list. And now I'm going to check the graph. So for UVW in as this, now EU minus 1 should append V minus 1 with W. Yeah, because I'm going to start from node 0, not 1. So for G V, excuse me, dot append with U minus 1 with W. And here I've already prepared the graph, the adjacency list. Now I'm going to prepare the Dijkstra array. So the Dijkstra array would be infinite times n and Dijkstra minus 1 because I'm gonna start from the last node, would be starting from 0. And then I'm going to prepare the PQ. So PQ would be just the empty array, and inside it would be a tuple. Inside, I'm gonna prepare the distance first. So from the last node, the distance is 0. The last node is n minus 1. So this means it's just dist and node for the priority queue. And I'm also going to prepare this modular because the result will be modular this value. Now I'm going to use the BFS, basically Dijkstra algorithm, to solve it. So while PQ, I'm gonna pop out the let me use maybe I use with variable. Let me I'm gonna use W. It is a weight. So W and U, I'm gonna use this node U would be equal to hip hop with this PQ. And now I'm going to check the neighbors. So for neighbor and the cost, so weight and cost are the same, but basically I'm gonna use this cost to say, yeah, because it's for neighbors. For neighbor and cost in G with the node. So the node is just U. Yeah, I will always put the weight at the first place because for priority queue, I'm going to check this weight first. I'm always check the shortest distance. Yeah, now I prepared for the neighbors and cost. I'm gonna prepare a cost. So this cost would be the previous cost W plus the current cost. It is my neighbor to the node, to this node U. Yeah, so for this neighbor, I'm gonna use the V, just two node. I'm gonna use a V. So the cost would be W plus C. Yeah. Now I'm going to check this cost. If my current cost is less than the distance, so the distance inside it would be a V. Yeah, because it is the distance for this node V. And this current node is also the distance to this node V. This means the last node to node V. Maybe the node V is just node 2. And if it is shorter, so I'm gonna update it. So if the cost is shorter, so the dist V would be equal to cost and yeah, priority queue should be push node with a cost and a node. Yeah, it should be the cost and the node. So the current node, its neighbor is V. Yeah. So this is the Dijkstra algorithm. Let me just return a value 0. It doesn't matter because I'm going to check if this list is right or not. Yeah, let me just print out the list to check what the distance array looks like first. Yeah, it doesn't matter. Yeah, because I don't prepare for that. I just check the distance array. As you can see, this is the distance array. So this is a 0 for node 5, and for node 4, it is a 6, and this is also 6. To node 3, it is 1. To node 2, it is a 2. To node 1, it is 4. It means it's right. Yeah, at least the Dijkstra algorithm is right. I get a right distance array. Yeah. Now, the second step is I'm gonna use DP. Yeah, DP is really hard to write. I'm gonna use the top-down approach. Basically, it is a DFS plus memorization. So I'm gonna start from this node 1 to other node. For example, from node 1 to node 2, if it is decreasing, so this is 4, this is 2, the distance, it is decreasing, I'm gonna check how many paths from node 2 to this node 5 to the last node. So there's one path. There are two paths because this is 1 to 5 to 2 and 5 to 3 to 2. There are two paths. Yeah. So how many distance from node 5 to node 3? There's only one path. How many paths? There's only one path just from node 5 to node 3. So in total, it's gonna be 3. Yeah. So let me prepare the DFS. So for the DFS, the DFS inside it would be a node. This node will be starting from we'll be starting from node last node, first node. So it's gonna be 0 because I'm always use the node 0 to n minus 1. It's not starting from node 1. Yeah, you can also use node 1. It always depended on your habits of solving this kind of a graph problem. Yeah. Now I'm going to check this node. If the node is the last node, n minus 1, so I'm gonna return a 1. So this means I find one path. Yeah, because to the first node to the last node, if I can go to the last node, it means at least I can find a path. Yeah, so this is the edge cases. Because from some node, from the start node to last node, if I can go from 1 to 5, it means at least there is a path. So I can return a 1. Now I'm gonna prepare a result. So for let me use a neighbor. For neighbor and weight in G with this node. So the result would plus all its neighbors. So for example, for this node 1, it would plus its neighbors. Yeah. So the neighbor would be, what is its neighbors? It is a DFS with neighbors. Yeah. But this is right. I think this is not right. Finally, I needed to return the result because I didn't check if the distance is shorter. Basically, if the distance is shorter, I gonna plus this DFS with neighbor. Otherwise, it would be too much. Yeah. Let me just run it. If not equal to n minus 1, maximum recursion depth exceeded in comparison. Yeah, this means there is an infinite loop. I didn't consider the distance would be shorter and shorter. If I didn't consider that, basically it would be an infinite loop. It will never end. So I needed to check it. How should I plus this DFS with neighbor? I needed to check the distance first. Yeah. So if the distance with neighbor, so my current node is the node. Yeah, if distance neighbor is less than the distance of my current node. So for example, this is current node is 1, the distance is 4. So if this distance is 2, so I'm not gonna go to this node. Yeah. If it is less than, result would plus DFS. Now let me run it to check. Now, as you can see, it seems works. Yeah. Now let me just run it. I'm sorry, I'm gonna submit it to check what's gonna happen first. Yeah, I know there are two things I need to add, but at the moment, if I didn't do that, I'm gonna make a lot of mistakes. First of all, I'm gonna make a time-limited mistake. Let's check. I can go to 52 because they designed this kind of testing case will never let you pass. So this means I have to use a cache. Because after using cache, the time complexity for the DFS, it is just O E plus V. E is the number of edges, V is the number of vertices. And for the Dijkstra algorithm, it is basically E times log V. So the time complexity will be n log n after I used the cache. Yeah, now let me run it and submit it to check what's gonna happen. There will be still a mistake. Yeah, because I didn't consider the mod. Yeah, so this is why we are practicing, we need to consider a lot of things. Yeah, as you can see, for this testing case, 69, and the number is too big. So this means I need a modular. After modular the mod, I think I can pass for all the testing cases. Let me just try it again. As you can see, it passed and it's pretty fast. Thank you for watching.